Okay, so these are our Unit 5C, Notes 5C1, rational exponents. Okay, so let's review our properties of exponents. You don't necessarily have to copy these into your notes. Just kind of review them because these were on that handout I gave you after the test. And they were up in that little box. So, I mean, you can write them down, but you don't have to. So, when we have two of the same bases that are being multiplied, we add their exponents. When we have one base with two exponents, this is what we call the power of a power, meaning that we have like a to the m and then we're raising that to the nth power. So, when you have a situation like this, you multiply your exponents. The next rule is, if you've ever heard me in class, this is what I refer to as the Oprah rule. It's like you get an M, you get an M. Everything inside that parentheses gets an M as an exponent. So that's why, that's cassette. That kind of reminds me of Oprah. You get an M, you get an M. Now this is our negative exponent rule. So just remember, if it's negative in the top, it goes to the bottom and it becomes positive. Vice versa, if it's negative in the bottom, it goes to the top and gets positive. If I have two bases, two alike bases that are being divided, I simply subtract their exponents. A over B to the nth power. This is like the Oprah rule, but it's with division. So you get an M, you get an M, everybody gets an M. And lastly, this is kind of a cool power, a property. I don't know why it's cool. It just kind of strikes me as cool. So if you have A over B, something in parentheses, to a negative exponent, what you can do is you can actually flip the inside and that exponent turns positive. And then you can apply the Oprah rule. If you get an M, you get an M. But if you think about it, A to the negative M, he's negative in the top, he goes to the bottom. B to the negative M, he's negative in the bottom, he goes to the top. So if you forget this rule, it still is possible to get to the final result using your other rules. So let's look at our first example. And again, this is from Algebra 1. They want us to simplify this expression. So we're going to do the Oprah rule on top. Everybody gets a 3. You get a 3. You get a 3. You get a 3. You get a 3. And on the bottom, it's the Oprah rule, but with 2. You get a 2. You get a 2. You get a 2. You get a 2. Now, on variables where you already have an exponent, remember that becomes the power, product of a power. Or power of a power. I apologize. It becomes the power of a power rule. So you end up multiplying the exponents. Now, you're probably going, oh my gosh, do I have to show this much work? Answer, no. Okay, a lot of this you can do it in your head and that's totally fine. So this step right here, you don't need to show. However, I would like you to show the next one because if you try to do all of this in your head, A, you don't get any credit because you didn't show any work, but also you're more likely to make mistakes. So 2 cubed is 8, that becomes a to the 6th, b to the 9th, c to the 12th, over 16a squared, b6, c squared. Okay, now we simplify. 8 over 16 is 1 over 2. Now, when it comes to the variables, yes, you can just do top minus bottom, but there's actually a little trick you can do. What I like to tell everybody to think about is, okay, so you find where in the terms of the A, you find out where your biggest exponent is. If it's in the top, you're going to write your answer in the top. If it's in the bottom, you're going to write your answer in the bottom. And then you just simply, for the exponent, you do high minus low. So when you go through that process, you end up with a to the 4th, b cubed, c to the 10th, all divided by 2. Okay, example 2. I want you to try this problem on your own. So pause the video, try it, and then I'll give you the answer. Okay, by now I assume you've started back the video, and this is what I got. Did you get it? So just a little word to the wise, anything to the 0th power is 1. So g to the 0th is really 1. So 2 times 1, we can get rid of that. And that's why g to the 0th does not show up in your final answer. Okay. Okay, so let's look at example 3. So example 1 and 2, they were kind of algebra 1, something you'd see in your algebra 1 class. Now we're getting into the algebra 2, the rational exponent. Now let's remember our definition of rational. Rational is any number that can be written as a ratio of a to b. In other words, any number that can be written as a fraction. Okay, so the rational exponent's kind of like the fractional exponent. Now, I know this looks a little funky the way it's written, but it really should be typed. It's just because of the exponents and everything. But what this really is a to the 1 over nth power. So my exponent is 1 over n. Okay, so when you're looking at a rational exponent, a fractional exponent, the denominator is always the index of the radical. And what I mean by index is that tells you what kind of root is it. Is it a square root? Is it a cube root? Is it a 4th root? Is it a 5th root? And so on. That denominator of that exponent, that's what goes in the little crook of the radical. Okay, so again, it tells you square root, cube root, whatever. The numerator is always the exponent. Okay, so in the case of a to the 1 over n, it just becomes the nth root of a. Because in this section, we're going to be changing rational exponents to radicals and radicals back to rational exponents. So this rule can go either way. So the nth root of a is the same as a to the 1 over nth. Okay, so for example, let's look at our first example. If I have 27 to the 1/3 power, using my rule above, I can convert that into that 3. Remember, that's my index. I can convert that into the cube root of 27. And then, of course, the cube root means what times itself? 3 times gives you 27. And it would be 3. So that's cool if your numerator of your exponent is 1. But what if it's not 1? What if it's something other than 1? So in the case of this is a to the m over nth power. So your exponent is m over n. Now, just like we talked about on the example to the left, your denominator is always the index. That hasn't changed. That denominator of that exponent is your index. It's telling you what kind of root it is. But the numerator, that is the exponent. That is the exponent of the problem. So what that means is that's the nth root of a to the mth power, or it's the nth root of a all to the mth power. Now you're probably wondering, well, what do I do? Which way do I do? Do I raise that a to the power and then take the nth root? Or do I take the nth root of a and then raise that answer to the mth power? And the answer is yes. There's really no hard rule or hard and fast rule to what you do first. Sometimes it might be easier to raise that a to the power and then take the nth root, or it might be better to take the root first and then raise your answer to that power. Okay, now I will tell you going forward that you will not be allowed a calculator on this test. So it's just going to depend on the situation, and the problem. So sometimes you might do one way and then another time you might do the other way. It's a problem by problem basis. So take, for example, here, 27 to the 2/3 power. Using my rule, that means 3 is my index. It's the cube root. And so it ends up, and then 2 is my exponent. So we get to decide, do we want to find the root first or do we want to find the power first? So let's do the power first. So again, remember you don't have a calculator. So in this case, if we do 27 squared first and then take the cube root. Now I don't know about you, but I can't, without doing a little scratch work, figure out what 27 squared is. I don't know it off the top of my head. So I would have to do a little scratch work and go 27 times 27, and that's 729. Same situation here. Off the top of my head, I don't know what times itself 3 times is going to give me 729. But we know it's 9. Okay, so that's if you raise it to the power and then you take the root. But let's try it the other way. Let's take the root first and then raise it to the power. So in this case, I'm going to take the cube root of 27, which is 3, and then I'm going to square it. So I'm going to take the root and then square versus square and take the root. So 3 squared is 9. Now, I don't know about you, but if I'm trying to do this on a test or quiz without a calculator, option 2 works better for me. But to each his own. You just have to decide what works best for you and what works best for the situation. All right, so now I want you to try these. You're going to convert to radical form and you're going to simplify where possible. So pause the video, try these, and then hit play again when you're ready to check your work. Okay, so 8 to the 2/3 simplifies to 4 after I convert it to radical form. 2 to the 5/2, that becomes 4 square roots of 2. And 1/3 to the negative 3/2, well, remember you got to flip him and he goes positive, and then you can convert to radical format and simplify. And it becomes 3 square roots of 3. Now, if you go to the end of this video, this is slide 5, I believe. And if you go to the end of this video, I have an extra slide where I have actually worked out these 3 problems. And so that way you can follow the work. But it's at the end of the video. Okay. How about these? Okay. Again, one thing you'll notice on all these slides, assume all variables are positive. Assume all variables are positive. That way, we're allowing you to assume that. That way, you're not having to put absolute value bars around all your variables and stuff like that in your answer. So that's why you're seeing assume all variables are positive. Okay, so what we're going to do on this slide is I want you to convert to radical form and simplify where possible. Okay, so pause the video. Try these on your own, and then start again when you're ready to check your answer. Okay, so for the first one, I got the square root of x. That became the 5th root of a squared. Cube root of c. 3 cube roots of 3. And 3 square roots of 3. Now, this is slide 6. Again, if you go to the end of the video, I have got a slide built in where you can actually pause it and see the work. Now, the first 3, they were kind of evident what they were going to become, but I did show the work for the last 2. So you don't see the first 3, but I do have work for the last two. All right, so in those previous examples, we were going from rational exponent to radical. Now we're going to go the other way. We're going to go from radical back to rational. Don't simplify anything. All I want you to do is convert forms. So pause the video, convert these from radical to exponential form, and then hit play when you're ready to check your answers. Okay, so I got c to the 1/2, m to the 1/3, 4 to the 2/3, 4 to the 2/3. And you're like, wait a minute, that's just showing you that in the third example, they took the root and then squared, but in the fourth example, they squared and took the root. Ultimately, changing it back to rational exponent form, it's the same problem. And then lastly, 8 to the 2/3. All right. Okay, so let's put it all together. We are going to look at a problem. Square root of x divided by the 4th root of x. Now, prior to today's lesson, you couldn't have done this problem. You can't divide a square root by a 4th root. However, thanks to rational exponents, we can. So, I'm going to convert the square root of x to x to the 1/2. And I'm going to change the 4th root of x to x to the 1/4. Now I just use my exponent rules of subtraction. Now those do not have a like denominator, so I've got to convert them to a like denominator, which is 4. So then I have x to the 2/4 minus x to the 1/4. Well, 2/4 minus 1/4 is 1/4. However, I started this problem with radicals, so I have to convert the rational back to a radical. And that gives me the square root of 4. I apologize, not the square root, the 4th root of 4. Let's look at this guy. Now here, we're going to use the Oprah rule. You get a 2/3, you get a 2/3, you get a 2/3. So that becomes negative 8 to the 2/3, x to the 2/3. Now, here's where we kind of run into the situation. We can't clean up the square root of xy to the 2/3. But what we can do is we can change the square root of xy to xy to the 1/2. So the square root of xy is going to become xy to the 1/2. And then we can apply the 2/3 exponent. So we're going to take this piece by piece. So for example, negative 8 to the 2/3. I'm going to convert, because I can't deal with a number to the 2/3, I got to change it back to a radical. So I'm going to change that to the cube root of negative 8 squared. Now, could I have done the cube root of negative 8 squared? Yes, but cube root of negative 8 is negative 2. Negative 2 squared is 4. Okay, so that's as far as we can take that piece. Now we go to the next piece. Well, x to the 2/3, you can't really do anything with right now. So we're going to just let him come down. However, if you look at 1/2 times 2/3, do you see how you have a 2 in the denominator and a 2 in the numerator? Those can cancel out. If you didn't see that and you got 1 times 2 is 2, 2 times 3 is 6, 2/6 does reduce down to 1/3. So when you're dealing with these, you always want to deal with your exponents in simplest form. Okay, so if you have a fraction and it can be reduced, please reduce it. So now we can do the Oprah rule on xy to the 1/3. You get a 1/3, you get a 1/3. Now, if I'm looking, oh my gosh, I see two x's right there. I see an x to the 2/3 and an x to the 1/3. So what I can do right there is I can use my properties of same base being multiplied and add those exponents. And then, of course, y to the 1/3 comes along for the right. Now, 3 over 3 is 1, so that becomes 4x. But remember, you started with radical form, so you got to leave it and end in radical form. So we change that y to the 1/3. We change that to the cube root of y. So we end up with 4x times the cube root of y. So all in all, not too bad. Now, you try these problems. So pause the video, try them, and then hit play when you're ready to find out the answers. So on the first one, I got x is equal to 8. Second example, I got y to the 6th over 8. Third example, I got 1 over 16. Fourth example, I got v cubed times the 5th root of v squared. Now that one I will go over, and I'll show you how we did that. And then the simplification one, I got 1 over 4b squared c4, c to the 4th. So again, this is slide 9. So at the end of this video, I do have these problems worked out. Set of examples. Now these are a little bit of a brain teaser. These are definitely taking it to that next level and challenging. Okay, so prior to today, I could not multiply a 4th root by a square root. However, with rational exponents, I can. So I'm going to change that to 12 to the 1/4 times 18 to the 1/2. No, you cannot multiply them together just yet. But if I break 12 down to its prime factorization, you know, kind of like when we're trying to simplify a radical and we go 2 times this, this breaks down into 2 times this, do that with 12 and 18. So if you do that, 12 breaks down into 2 times 2 times 3 to the 1/4. And 18 breaks down into 2 times 3 times 3, because that makes 18, to the 1/2. From here, guys, it's just the Oprah rule. You get a 1/4, you get a 1/4, you get a 1/4. And then the next one, you get a 1/2, you get a 1/2, you get a 1/2. Now, what I'm going to do on my next step is I'm going to combine, because remember, multiplication is commutative, meaning 2 times 3 is the same as 3 times 2. The order of the multiplication does not matter. So I am going to put all my 2's together, and I'm going to put all my 3's together. And also, remember, if you're multiplying the same base, you add their exponents. So I kind of did 2 steps there in one. I combined all my 2's and then added their exponents. Combined all my 3's and added their exponents. Now, I need a common denominator. So on the 2's, my common denominator is going to be 4. And on the 3's, my common denominator is going to be 4. So got them all in common denominators, and then 1 plus 1 plus 2 is 4, and 1 plus 2 plus 2 is 5. Now, 4 over 4, that's 1. So what I'm going to do at this point is I'm like, ooh, 5 over 4. That's kind of like 4 over 4 plus 1 over 4. So I kind of split my 3's back up. Okay, so do you see right there how I split that back up so I have a whole number? 4 over 4 becomes 1, and that leaves me a 1/4. Now, the 4 over 4, those are just 1. So that becomes 2 times 3, and then 3 to the 1/4. So 2 times 3 is 6. That becomes 4th root of 3. And you're like, holy Toledo, Batman. Oh my gosh, that's a lot of work. That's why you only have like 1 or 2 problems of this, because they do require a little bit of work. But they're not unfathomable. We can, I don't even think that's a word. I apologize. They're not impossible. We can do them. They just take some work. Last example. Again, another fourth root being divided by a square root. But first step, you can't do this. So first step is you always have to change it to a rational exponent. So to the 1/4 and the 1/2 power. And now we just do the Oprah rule. You get a 1/4, you get a 1/4, you get a 1/2, you get a 1/2. And I know you're probably thinking, why didn't you just change that to 8/4 to be 2? You can do that, but then look at your bottom. You are dividing by a 1/2, a y to the 1/2. So I left everything in fraction form so that I could just do a common denominator and make it all easy. So the top denominators are 4, so I'm going to make the bottom denominators by 4. Or, nope, I lied. I apologize. I reduced them all to have denominators of 2. My bad. But you could have also changed them to 4 and you would have gotten the same result. So 2/4 changes to 1/2 and 8/4 changes to 4/2 if I reduce them to have denominators of 2. But again, you could have changed the bottom ones to be 4. You would have ended up with the same answer after you simplified. So, right here, if I'm looking at the x's, I see 4/2 is bigger than 1/2. So my x is going to stay on the bottom, and 4/2 minus 1/2 is 3/2. Now on the top, in regards to the y's, the y on the exponent on top is bigger, so my y is going to go on top, and it's going to be to the 3/2. Which is basically what I'm showing here. So your x goes to the bottom. Now, you could have skipped those 2 steps in between if you had done what I talked about and said, okay, the x is bigger on the bottom, so I'm going to put my answer on the bottom. And the y is bigger on top, so I'm going to put my y answer on top. But again, I showed every step just in case anybody likes all the steps. So I'm going to convert that to radical format. So the square root of y cubed over the square root of x cubed. Now, if you were to break down your factor tree, you'd have y times y squared would become y times y. You'd circle the 2 y's, 1 y would come out, 1 y would stay in. Same thing with the x's. X times x squared breaks down into x times x. You have 2 x's, 1 x comes outside, 1 stays in. So we end up with this. Now you're like, woohoo, I'm done. Almost. Remember back in geometry, and we talked about it a little bit in Algebra 2, we cannot leave that square root of x on the bottom. Square roots on the bottom are very bad, okay? So the x on the outside, he's fine. He's cool. He can hang out there as long as he wants. But the square root of x, not so good. So we have to rationalize. So we're going to multiply the top and the bottom by the square root of x. Okay, top and bottom. Because if to get rid of it out of the bottom, you've got to multiply the bottom by the square root of x. But remember, what you do to the bottom, you do to the top, because you have to keep your fraction equal. So I rationalize. Now, up on the top, that gives me y times the square root of xy. On the bottom, the square root of x times square root of x is square root of x squared. But the square root of x squared is x. So x times the outside x is x squared. Now, we're going to do more work with problems like that on day 2. We'll do more work with it, so don't panic. Do not panic. This is just kind of giving you, this example right here is giving you a little bit of a preview of what's to come on lesson 5C2. All right, so that's the end of the formal PowerPoint, but I just want to show you. If you go to the next slide, I've got slide 5 problems worked out so that way you can see how I went from point A to point B to point C. So if you want to pause the video so that you can write those problems down, you're more than welcome to. And then if you go to the next slide, there's those 2 problems I told you that I would work out and show you. Now, the one thing I do want to point out, obviously the one on the right is pretty simple. We've simplified radicals before, square roots. However, one thing I want to point out, and again, we're going to talk more about this on lesson 2, is if you look, that becomes the cube root of 9 squared. Well, there is no cube root of 9, so you got to do 9 squared, which is 81. So you got to do the cube root of 81. So I still break it down like you would if it was a square root. You break it down the same. But instead, in a square root, we circle in groups of 2. However, if it's a cube root, we circle groups of 3. Okay, if it was a 4th root, we'd circle things that we have 4 of, 5th root, things that we have 5 of. But in this case, it's a cube root, so we've got to circle things that we have 3 of. So in this case, we have 3 3's. So they come outside of the radical as 1 3, because think about it, 3 times 3 times 3 is 27. Cube root of 27 is 3. So that's why it comes out as 3. And then you have that little fella that's left behind, and he stays back underneath the cube root, because he didn't have 2 other buddies to come outside and hang out with. So anyway, so just FYI of things to come. And then slide 9, pretty much those I think you should be able to figure out without explanation, but let's look at the one on the bottom right hand corner, that v to the 17 over 3 all to the 3/5 power. So the one thing I noticed is that there was a 3 on top and bottom, canceled them out. That gave me v to the 17 over 5. Well, 5 goes into 17 evenly 3 times, and you have a 2 remainder. So what I did is I broke that 17 over 5. I broke that up into 15 over 5 because that's going to become your 3. And then you had 2 over 5. Well, 2 over 5 can't simplify anymore, so you put it back in radical format, and it becomes the 5th root of v squared. But again, I'm going to show you a better way to do this on day 2, but I didn't want to jump into day 2 topics on the day 1 PowerPoint. But this is another way to do it. But I'm going to show you an easier, quicker, better way on day 2. So, and then if you look here, I ran out of room, so I had to put that last example here, that simplify. But there's all the work for the simplify. Okay, so this concludes our PowerPoint and our lesson. So your homework is 5C.1. It's a worksheet. It's already on Canvas. So if you have any questions, just holler at me. If not, I'll see you in class next time. Have a good one.